Hello everyone! Today we will be going over the last question in paper 1 of the sample assessment material for further pure maths. Now, this question, as you can see from the graph, there is a shaded area under a curve, so it looks like it's to do with integration. Figure 3 shows a sketch of this curve fx, which passes through the points -1, 0, b 0, and a 0. And given that the differential of fx is this expression here, find the value of a and the value of b. Okay, so a and b seem to be two other solutions of the equation rather than -1. So what I expect we'll need to do, we'll see that the integral of the differential of fx dx will be some expression plus c, and we'll need to use the fact that f of -1 is equal to 0 to find out this c before we can find out the full equation of fx, and then we will divide fx by either x plus 1 or some multiple of x plus 1 in order to find some quadratic equation that we can solve for the other two values, because this is a cubic equation currently, and we want a quadratic equation which will be easier to find the answers to, and we can find the values of b and a. Secondly, they want us to use algebraic integration to determine the exact value of the total area of the shaded regions shown in figure 3, which basically is, I'm fairly certain you hardly even need to read the question on this one. Obviously, you should be reading the questions, but they want you to find the exact value of the total area of the shaded regions. Now, area is always a positive if it exists. So, since this is above the x-axis, and this is above the x-axis, it will be the positive of the integral from 0 to b of fx. And since this is below the axis, the area will be the absolute value of, or the minus of the integral from b to a of fx dx. And then we will add these two together to find the total area. Alright, so let's get started. The first thing we are going to do is integrate the differential of x. So, this is part A of our solution. If we integrate this, 6x squared with the power rule goes to 2 times x cubed, minus 26x goes to minus 13x squared, and plus 12 goes to plus 12x. Then obviously there's a plus c. F of -1 is equal to 0, which is equal to 2 times -1 cubed, so minus 2, and then minus 13 times -1 squared, which is positive 1, so still minus 13, and then plus 12x, where x is -1, so it's minus 12, and then plus c. And we work out from this, if you solve this equation for c, since it's just 0 is minus 27 plus c, you will find that c is equal to 27. Now, therefore, the full expression for fx is equal to 2x cubed minus 13x squared plus 12x plus 27. So now we will see what this is divisible by. Since there's a 2 here, we could either divide it by x plus 1, so we can use synthetic division for this, or we will have to use polynomial long division for dividing it by 2x plus 2. But given that some of these coefficients are not divisible by 2, I would argue that it would be best to divide this by x plus 1. So, synthetic division. How do we do this? First, you set up your calculation space like this, and then you write all the coefficients of the big polynomial you are trying to divide. So that would be 2, minus 13, 12, and 27. And then you would write the root of the little expression you are trying to divide by. So since this is a -1 here, we will be writing -1 here. So first we bring the 2 down, and we write 2 here. So this represents 2x squared because 2 times x plus 1 would be, because 2x squared times x plus 1, the first term would become 2x cubed, and then we have 2 times minus 1 to be minus 2, and this minus 2 represents the fact that you would subtract a positive 2x squared when doing this in the long division method. So this is really a shorthand of the long division method, specific to when you just have an x plus something that you want to divide by. So if we continue this process throughout evaluating the whole polynomial, you get 2 minus 15, and then minus 1 times minus 15 is 15. 12 plus 15 is 27, and then minus 1 times 27 would be minus 27, and you get the remainder is equal to 0. And we knew this remainder would be 0 because x plus 1 would be a factor of fx. So now we know that fx divided by x plus 1, where x is not equal to negative 1, is equal to 2x squared minus 15x plus 27. Now, we want to solve this quadratic equation, and since the first coefficient is not 1, we will have to solve it by factoring, and factoring by grouping. So, the two numbers, we're going to group the middle into a and b. The product will be equal to 2 times 27, which is 54, and then the sum of these numbers would be minus 15, because that is the coefficient of our single linear x term. So a plus b would be minus 15. So since it's a positive, both these factors will be negative. So let's list out the factors of 54 and try and figure out which two would be a plus b. So you have minus 1 and minus 54, obviously not correct. Minus 2, minus 27, also way out. Minus 3, minus 18, and that would be minus 21, so also not correct. 54 is not divisible by 4 or 5, so that brings us straight to 6, and you get minus 6 and minus 9, and this adds up to minus 15. So it looks like we have our two numbers. And then we need to decide which order we'll write the minus 6 and then the minus 9x. And I think we'll put the minus 6 first because we have a 2 here, and a 2 and a minus 6 share the common factor of 2, which we can factorize out. Truthfully, it wouldn't matter, but it is just much easier to do it this way. So we have 2x squared minus 6x minus 9x plus 27, and then we factor out the 2x, so we have 2x times x minus 3, and then we want the first term to be also x, so that we'll get x minus 3, so we factor out the minus 9 here, and it's minus 9 times x minus 3, because minus 9 times minus 3 brings us the positive 27, and then we factor out x minus 3 to get x minus 3 times 2x minus 9. So now we solve as if both sides were equal to 0, and you get the values of x to be 9 over 2 and 3. Now we look back to the beginning and we recall that the lesser solution, b, is b and the greater solution is a. This is kind of contrary to the logic you would normally follow, but you've got to pay attention to the question and make sure you're answering it correctly. So since b is less than a, b is equal to 3 and a is equal to 9 over 2. Now we have part A of the question complete, but we still need to do part B, which is the area. So what I think is the case is that since we have our graph here, and it looks like this, and this part is negative, and this part is positive, and this is from 0 to b, and this is from b to a, we will have to take the positive integral from 0 to b of fx dx, and then subtract, because the minus times the minus will make it positive, subtract the definite integral from b to a of fx. Alright, so let's get down to business. Firstly, if we just want to integrate fx quickly, this would be equal to the integral of 2x cubed minus 13x squared plus 6x plus 27 dx. And this would be equal to 2 over 4 x to the 4 by the power rule minus 13 over 3x cubed, then plus 3x squared plus 27x dx, or not dx since we have evaluated the integral already. So we want to find the bounds of this function from 3 to 0, and then minus the bounds of this function from 9 over 2 to 3. Because from 0 to 3 it's positive, and from 3 to 9 over 2 it's negative. So let's first work out what this is. So since when x is equal to 0, there is no constant term, and so all of these would end up being 0, because anything times 0 is 0, and then you would just find that the value of this from 0 to 3 is just when x is 3, this expression when x is 3. So if we call this part 1, and then we call this other one part 2, 1 would be equal to 2 over 4 times 3 to the 4 minus 13 over 3 times 3 to the 3 plus 3 times 3 to the 2 plus 27 times 3. And then minus 0 minus 0 plus 0 plus 0, because this is just equal to 0. So if you put this into a calculator and evaluated it, you would find that you got, so in my calculator I'm just using the assignment method, so I'm assigning 3 to a variable x, and then I will evaluate 2 over 4 times x to the power of 4 minus 13 over 3 times x cubed plus 3x squared plus 27x, and if we evaluate this all, we will find that it is equal to 27 over, or rather 63 over 2. Now, let me just check that I've integrated the correct equation here, because I am concerned that I have not done it correctly. Yes, indeed, I have not done it correctly. This should be a 6 times 3 squared, and this should be a 6x squared, and this should be a 12x. Remember to check your work. If you flip the page and you think you've memorized the function you're working with, as I have, you will make careless mistakes like this. And it is up to you to make sure that you're always checking and making sure that you are copying out different parts of your working correctly. So what I really should have ended up with is 117 over 2. I know this because I did a failed take of this question before, and I got this answer for the evaluation of the first part, and we need to make sure that we are always vigilant for looking out for these kinds of mistakes. So overall, this gets us to 117 over 2, not 63 over 2. And now we will evaluate the second part of the question, which would be the bounds from 3 to 9 over 2 of the expression again. So that's plus 6x squared and we know that this is just 2 over 4 times 9 over 2 squared minus 13 over 3 times 9 over 2 cubed plus 6 times 9 over 2 squared plus 27 times 9 over 2. And then, after all this, we subtract 117 over 2 because that is the value of this expression for when x is equal to 3. So, again, plugging this into a calculator, we set the variable x to be equal to 4.5 or 9 over 2 or however you want to do it. And we will get 2 over 4 x to the power of 4 minus 13 over 3 x cubed minus, or rather, plus 6x squared plus 27x. And that is equal to 1701 over 32 minus 117 over 2. So even though these fractions are with different denominators, you can just evaluate them in the calculator because that is probably the best thing to do. You want to make sure that you are not making any mistakes. And you'll get minus 171 over 32. So the negative of the integral from b to a of fx dx would have been positive 171 over 32. Now, finally, you want to evaluate the original sum we had with the new values that you calculated. So this would be 117 over 2 plus 171 over 32, which would be equal to 2043 over 32. So that is our final answer for the area between this curve and the x-axis. Now, I know I did make a mistake here, and I've left it in because it is important for you to ensure that you are not making the same kind of mistake in an exam. Because when you do, it can seriously mess you up, and you will end up losing a lot of marks for these kinds of silly errors. And if you're aiming for an 8 or a 9 grade, then you need to know that you can only afford to lose 4 or 5 questions over both papers. So even a silly error like this costing you an entire question afterwards will be quite detrimental to your ability to achieve a high grade like this. Alright, so to recap, we have taken this fact that f of -1 is equal to 0 to find the constant of integration here. And then we have solved the cubic equation with a lot of division and quadratic solving techniques to find the values of b and a, the other two roots of this cubic equation here. And then we have used integration to find the area of this, and the negative integral between b and a of this will be the positive value for the area of this, and we just add it together to find this shaded area. Alright, so let's go to the mark theme and see if we were correct. So, y is the integral of this plus c at the point -1, 0. Well, this is just a different and more bare bones way of writing out that f -1 is equal to 0. You get 0 is c minus 27, so c is 27. Yep, we got that correct. Then we take this, we divide it by x plus 1, we do this, we solve this quadratic equation. You get a is 9/2, b is 3. Yep. Then the area is the integral from 0 to 3 of this, plus, alright, these bars on either side, the pipe character, it basically means absolute value. So negative becomes positive and positive stays positive. We are just taking the negative of this because we know the entire integral is going to be negative. Alright, so the area is the integral of this from 0 to 3 plus the integral of this, or in our case minus without absolute value sign, the integral from 3 to 9/2 of this. And then we just evaluate the bounds here and add it up to get 2043/32. And so the area is 2043/32. I suppose it might not be necessary to write this final step here if you've circled your answer, but in future I would do that as well. This is something I've learned from this process, and you can learn it too. So just write something like, therefore the area is equal to this for a mark. Alright, 13 marks. Huge success. I wish you all a good, happy, and prosperous Chinese New Year holiday, and thank you for watching.